In the previous video, we created a simple console interface to the Printrbot where we could send it G-code commands and look at the responses. And now we're going to start actually working on a program that will print some interesting objects. And to get started, let's just take one step up from the console interface. So the console program that we created last time takes a string, which is a G-code command, and it sends it to the Printrbot Jr. And then it waits until the Printrbot Jr. has a response. It reads that response and it writes the response into a log that appears on the screen. What we're going to do this time is we're going to create an object in LabVIEW that represents information about something called a GCode sink. So a sink is something that you pour stuff into, just like you pour liquid down the sink at home and it goes down the drain. A G-code sink is going to be a place where you pour G-code. And the sink can go to a couple of different places. So you might have one sink, when you pour G-code into it, it goes into the printer, and this would go across the serial port. You might have another kind of sink where you pour G-code and it goes into a file. So you end up with a G-code file that can then be played back later. So that's what I've represented here in this little diagram. This is called a UML diagram for Universal Modeling Language, and there's a bunch of different kinds of UML diagrams, but this one is aimed at defining different classes of different objects and showing how they're related. So we're going to have a file sink, which is a place where you pour G-code and it outputs the information to a file, and it has some local data. So the first thing that a file sync has is it has an output file. And when you start the thing up, when you initialize it, it's going to create this output file based on a file name that you supply. And then every time you send a command to it, it's going to go into that output file. And then when you're done printing, when you've sent all the stuff down the file that you wanted to send, you're going to close the file. Now, alternatively, you could have a serial sink. And a serial sink, when you pour stuff into the sink, it goes down the serial port. So it's going to have local storage as well. It's going to have a printer COM port, which is a serial port. And so this is going to be the serial port that's attached to the Printrbot Jr, just like in our console version. And it's going to have the same interface. So there's going to be an initialize function. This time, instead of taking a file name, it's going to take a COM port name. And it's going to open the COM port and store that open COM port locally in the object. And then when we want to send G-code commands to the serial sink, they're going to be sent over the serial port to the printer. And finally, when we're done sending commands, when we're done printing, we're going to close the COM port. So close the serial sink. Now, we could just create these objects and create a version of the program that used file syncs everywhere, and then create another version of the program that used serial syncs everywhere. But that would be a lot of editing, because every time we write a G-code command to either the file sync or the serial sync, we have to call this send command function. It's called a method, actually. But we'd have to call that every time that we wanted to send a command. And then if we wanted to change from a file sync to a serial sync, so we wanted to create a new version of the program that wrote its output somewhere else, we'd have to go into the program and we'd have to find every single instance of sending a command to a file sync, and we'd have to replace that with sending a command to a serial sync instead. And that's a lot of work, especially if the program is very big. But one of the nice things that LabVIEW and object-oriented programming gives us is the ability to, instead of defining a program that uses a file sync or a program that uses a serial sync, instead we can create a new object class called a GCode Sink. And this is more general, more abstract than this or this. And if we write a program that accesses the G-code sink, that knows how to send commands to the G-code sink and knows how to close the G-code sink, then we can write the program using the G-code sink. And then if we supply a file sync, everywhere where we send a command to the G-code sink, it's actually going to use this send command on the file sync. So we know how to pour commands into an abstract sink, and then if we're using a file sync, it uses the file write, and if we're using a serial sync, it uses a serial write. So the key to making this all work is that these two sinks, the file sync and serial sync, have to present the same interface. So they know how to close the sync and send a command. And the only interface that we're going to expose in this GCode sync is the ability to close a command, to close the sync, or to send a command to it. So we'll see how this actually works in a few minutes. Let's actually go ahead and start roughing it out. So I've created an EET 241 folder, and I'm just going to create a new folder in here for my sync demo. And let's go ahead and start up LabVIEW. It's actually right over here. So let's go ahead and create a new blank project. And we'll just go ahead and save that into the folder we created, which is EET241 sync demo. And we'll call that sync demo. So let's start by creating this GCode Sink. And it's a pretty simple object. It just has basically a name, and it's got a close command and a send command. So I'm going to create a virtual folder as just like a convenient place to put the sinks. And under here, I'm going to create a new class. And what this gives me is one thing so far. So object classes have private storage. And what a private storage is basically looks like an interface, and it's got this little cluster of data here where I can drag and drop various, numbers and strings and other more complicated kinds of objects. And I can just put them in here, and then anywhere inside of this GCode Sink class, if I define VIs under GCode Sink, they can all access this data. But anybody else outside of the GCode Sink is not allowed to access this data. And it might seem like it makes life more complicated to do it this way, but in fact there are some advantages that we'll be talking about in later videos. So for now, just know that there is some private data here that I can access through all the VIs I define under this class. And for the GCode Sink, we don't have any. That's why this little thing is blank here, because we don't need any local storage. But we'll go ahead and we'll save this. And I'm going to create a new folder inside of my sync demo to hold all the stuff associated with my GCode Sink class. And I'm going to save my class definition inside of there. Now, the sink that I've defined, it has two methods. A method is like a VI that's attached to an object. It's got close and it's got send command. And we're going to go ahead and we're going to create a new dynamic dispatch template. So what this actually is telling LabVIEW is that I'm going to define a method on this object, but I'm not actually going to tell you what it does. It's going to be something that all of the subclasses use. So for example, if I want to close a GCode Sink, how do I close that sink? Well, you don't know, because it depends on what kind of sink it is. If it's a file, you close the file. If it's a serial port, you close the serial port. But those are different kinds of things. So I don't actually know how to close a GCode Sink. I don't even know how to send a command to it. I mean, where does the command go? I haven't hooked this sink up to anything in the real world. It's abstract. I know I need to be able to send commands to sinks, but I don't know how to actually send a command to just a generic GCode Sink. So what I want to do is I want to tell LabVIEW that I'm going to sort of define this interface that the GCode Sink is going to have these methods, but I'm not going to actually implement exactly how they work. Instead, if I try to call send command on a file sync, then it will use the specific send command here. Or if I try to call send command on the serial sync, it will use the send command here. So this is called a dynamic dispatch in LabVIEW terms. And what it is a way of saying that go ahead and wait until you actually know what kind of object this is. And instead of calling the GCode send command, instead dynamically dispatch to this send command or dynamically dispatch to this send command. So from this guy, send command is a dynamic dispatch. And then later on when we define the file sync, this guy will be called an override. So send command here overrides send command there. So those are what the terms mean. And for now we're going to, as I said, just create a dynamic dispatch template. And what we get is the GCode sink in and out, error in and out, and we also get in the block diagram, it's got a little case condition. So it's first checking to see whether this error in is error or no error. If it's no error, then we execute this code, which just basically passes the GCode sink through and the error through. If there is an error, it just does the same thing. It passes GCode sink in and error in and passes them back out again. So this doesn't actually do anything. It just sort of stubs it, but that's fine. So we'll go ahead and we'll save this. And we're going to save it in the same folder, our GCode Sink folder, where we saved the class. But we're going to name it. So this one will be our close VI. And there's one other thing that we can do here, which is, let me make this window a little smaller. You'll notice that this is all sort of blank and not very useful. And when we drag this on the screen, we're not going to be able to tell what it is. So I'm going to customize this just a little bit so I can tell what it is. And the first thing I'm going to do is I'm going to define for all of the VIs on this class and for the object itself, I'm going to define something that's a little custom just so I can tell what it is. So to do that for a class, I right-click on the class and I go to Properties. And under General Settings, I can edit the icon. And all I'm going to do is on this icon text, I'm just going to say what kind of object it is. So this is a GCode Sink. And I can see GCode Sink here. And it's asking me for all of the VIs that I've defined under this class, whether I want to update their icons, and I say yes. And now, if I look at my closed VI, I see that it's filled in this GCode Sink part. But it's just basically numbered this VI. And so if I had this on the palette, I could tell it was something associated with a GCode Sink, but I couldn't tell what it was actually doing. So I'm going to edit this one as well by double-clicking on it. And the first thing I'm going to do is going to get rid of this 1 here. So under Layers, I click on this layer that has the 1 in it and just get rid of that. And under icon text, I'm just going to say close. So now my icon will say GCode Sink and it will say that it's the close method, and I can tell what it actually does on my diagram. So that's everything I want to do here. And let's do the same thing for send command. So go ahead and save all. So this time I'm going to create a new dynamic dispatch for send command. And see, I get the same block diagram, does the same thing as before, which is basically nothing. And let's go ahead and edit the icon for this. Now, if I type command, it doesn't fit. So I'm just going to say CMD here. And I'm going to save this as send command. So I've defined 2 dispatch, dynamic dispatch methods on my GCode Sink class. But they're not exactly what I want. First of all, send command doesn't actually take a command. So what command am I sending to this thing? Well, I need a wire. I need a pin on this guy. that is going to take the command. I don't actually have to hook it up to anything because I'm not actually sending the command anywhere, but I do need to define file syncs and serial syncs that do take commands. So I'm going to go ahead and add a text control, and I'm just going to call this command, and I'm going to wire this in here and save it. Now, any send command method that I define on a subclass of GCode Sink, that will also take a command now. Now for close, after I've closed the GCode Sink, I want it to basically go away. I don't want to be able to talk to this sink anymore. And so the fact that it's being sent to GCode out, GCode Sink out, that's a problem. So I'm going to get rid of this on this VI. And now I have a little problem because this is gone, so I just have a dead terminal. So I'm going to remove that loose end, and I'm going to delete the wire. There, delete that too. So now I have it coming in, but I don't have it going out. And I have to do both the error and no error cases. Great. So now the close method is going to take a GCode Sink in, but it's not going to produce anything. So that's everything I need for my GCode Sink. Let's go ahead and create a serial sync now. So under syncs, I'm going to create a new class called serial sync. And this time I actually do have some local data. What I want to store is going to be this printer COM port. So I go ahead and under modern IO Visa resource, I just go ahead and put one of those in there. And let's call that printer COM port. And now any of the VIs I define on my serial sync will be able to access this printer COM port. So let's go ahead and save this. And once again, I'm going to create a new folder for my serial sync. And I'm going to save my serial sync inside of there. And let's go ahead and tweak the icon a little bit. So, oops. Actually, what I want is this guy here under Properties. Edit icon. So this guy is going to be a serial sync. And I also want to define inheritance. So if we look at our UML diagram, you'll see that serial sync inherits from GCode Sink. That means that the interface that I define here is matched by this guy. And anywhere I pass in a GCode Sink in my code, I can also pass in a serial sync. So to make this connection, I go to Inheritance, Change Inheritance, and now I can select the class that inherits from. So right now it just inherits from LabVIEW object, and everything starts out inheriting from LabVIEW object. But I wanted to inherit from GCode Sink. So I say inherit from selected, and that's it. So now I've defined a serial sync object class that inherits from GCode Sink, and I've added a printer COM port to the local storage. Now I have to implement these two functions, these two methods, close and send command. So let's do close. Actually, let's do it in a slightly different way. Let's do it the way that we did it in the console. So in the console, the first thing you do is you want to open the connection, and then you want to send commands to the connection, and then you want to close the connection. So the first thing I want to do is I want to open the connection. So I'm going to create a new VI from static dispatch template. So this is just like a regular VI here, except it starts with some things filled in. So serial sync coming in, serial sync going out, error coming in, error going out. And I have a simple block diagram as well, just like I had before. But this is going to be my initialization. And so let's go ahead and change the icon so we know what we're working on. And get rid of that 3. And I don't have enough room for initialization. I can just type init. And let's go ahead and save this guy. And he goes in the serial sync folder as well. Call him initialize. So in order to open my serial sync, I need to have a COM port. So let's go ahead and wire one of those guys up. And oops, those are an I/O Visa resource. And we'll call that printer COM port. And let's go ahead and attach that to a pin. So in the error case, I don't want to do anything with it. In the no error case, I want to go ahead and function palette. Just as before, under Instrument I/O Serial, I want to configure the port. And let's start hooking this up. So my COM port goes into the Visa resource name, and then I need to specify the baud rate. So I right-click on that pin and say create constant. And it gives me 250, which is what I used last time. So that's actually the number that I want. And I also want to specify the timeout, so I right-click and create a new constant there. And I had used 240,000 last time in the console application. I used 180,000. So 180,000 is 3 minutes, 240,000 is 4 minutes. Either way is fine. And then I need to wire in the error in and the error out. And now, what do I do with this Visa resource name out? Well, what I want to do is I actually want to store it in the serial sync object. And I have that local storage that we looked at before. So right here. So I have this local storage printer COM port. So this is actually where I want to put that COM port. So let's look at how to do that. I'm going to delete this line. And I'm going to create something called, if I right-click on this, under Cluster Class and Variant Palette, I get Bundle by Name. And Bundle by Name, it's going to take a cluster or an object coming in here at the top called Input Cluster. And what it gives me is a little palette I can select from all of the stuff that's in that local storage. So right now I only have one thing in there, printer COM port, so that's all I can select from. But if I go ahead and wire this Visa resource name out into printer COM port, this takes in this object, it sets this piece of data, and then it returns the object with that piece of data set and everything else the same. So I can just wire that to my output pin. And now I have an initialize method that takes a printer COM port and configures that port and stores the port on the object and returns the object with the correctly configured port. Now I can go ahead and look at sending a command. So this time when I right click, if I say new, you'll see that I have something called VI for override. And this is grayed out unless serial sync inherits from some other class, and the other class defines a dynamic dispatch method. So since GCode class defines two dynamic dispatch methods, close and send command, and serial sync inherits from GCode Sink, now I have this VI for override available. And if I select that, it shows me the two methods that I can override. So I can override close and I can override send command. Let's go ahead and do send command. And you see when I do that, this time It includes a command now because I had defined that command in the dynamic dispatch. So now it's available in the override as well. The interface here, the pins, they all have to match exactly. So if I have a cluster or an object or whatever coming in, I have to have exactly the same thing in this interface here. So how do I send a command to a serial port? Well, what I get as the default for this override is this little icon here with this thing on it. This is just calling the send command that's defined on the GCode Sink. So it's saying that the default way to send a command to a serial sink is just do whatever you did on the parent object. But I know that this isn't actually doing anything, so I need to define something a little more specific here that works for serial sinks. So I'm going to delete that, and I have a bunch of loose wires. Let me just clean this up a little bit and give myself a little more room here. So give myself a lot more room here. Actually, let me unpin this, move it over here, because I'm going to grab a couple of these guys. So this part is going to be just like in our console application. So we're going to go to Instrument IO Serial, and the first thing we want to do is write the command, and then we want to wait until there are bytes at the port, and then we want to read a response, and then we're going to just pass it through. So that's how we're going to send a command. And let's go ahead and add the same kind of case structure that we had before. So under Programming, Structures, Case Structure, let's wire the error to this condition. So now if there's no error, then we do this stuff. If there is an error, we do that. So what do we do if there's an error? Well, we just pass the error box through, and we pass the serial sink through. And we don't do anything with the command. So if there's no error, the first thing we need to do is call this write command. And this write command takes a VISA resource name. So what we have is a serial sink object, and what we need is a VISA resource name. But we know the resource name is the COM port that's inside of this object, inside the local storage of this object. So the way we get at that, if I right-click here, is unbundle by name. So this guy attaches right here, and now I have a list of all of the things, the properties that are associated with that private storage. And since there's only printer COM port, that's the only one I get, but that's the only one I need right now. So this gives us a VISA resource name that we can wire in, and we have our command, and we have our error. And now we want to have a while loop. So while we don't have bytes at port, we're just going to continue looping. So let's go ahead and draw one of those in. And move this over a little bit. And move this over a little bit. So I'm going to continue looping here until the number of bytes at port is greater than 0. So when this is greater than 0, I'm going to stop looping. And now, at the end here, I have a VISA resource name out that I need to somehow wire into this serial sink object. And the way I do that is just like before, using bundle by name. And bundle by name, I need to wire a cluster of the right type in, but I have one of those over here, so I can just sort of connect this over to here. And I'm going to give myself a little more room. So now I can take this Visa resource name in, I can set the printer COM port based on that, and then the resulting object goes to the serial port. So that's it. So that's everything for sending the command. If I have no error, move this down a little, move this up a little. So if I have no error, I go ahead and I send command, wait for the response, read the response, and then put the printer COM port back into the object. If there is an error, then I just pass those two things through. So let's save this. And under serial sync, I'm going to save it as send command. Now I have a little error, so let's take a look at this error and see what I have. So Visa read contains unwired or bad terminal. Because I have to pass the number of bytes through as well. So let's go ahead and link that in. So that goes there. Let's clean this up a little bit. There. Yeah. Not very beautiful, but it will work. So now my error's gone away, and now I'm done with that. So now I have a serial sync that I can send commands to. We'll save all. Now I need to implement the close. So let's go ahead and do the same thing. We're going to right-click, new VI for override. Override the close method. And you'll see I have one serial sync coming in and no serial syncs going out. It already has close for the method name because it inherited that from the GCode Sink that I defined before. So once again, we're going to get rid of the call to the parent's close. And to close the port, we just are going to use this close here. So we have to unbundle by name again. So there's our COM port, and we're going to wire that in here. And we'll go ahead and wire the error line in. And we'll wire the error line out. And that should be it. So we'll save that as well. So now let's go ahead and write a program, a simple program that uses this serial sync. And let me go back to the project. So let's create a new VI called home. And this time we're just going to save it under sync demo. So the home program is going to take a GCode Sink as input. So I just drag that over. And it's going to return a GCode Sink as output. So I just copied and pasted. So this is going to be GCode Sink in, and this will be GCode Sink out. And I'm going to change this to an indicator. And I'm also going to add error in and error out. So that's under array, matrix, and cluster. So I have an error in. And here's my error out. And let's go ahead and wire those things in. And go to the block diagram. So what does the program look like? Well, the first thing we're going to do is we're going to send a command to the sink to home the machine, and that's it. So let's go ahead and wire that in. Actually, we delete wire branch, and check for the error condition. So if there's no error, then we'll go ahead and we'll home the machine. And let's hook these up as well. Okay, so to home the machine, the command that we want to send is G28 followed by a new line. So we're going to create a new constant, and G28, and I'm just going to hit the return key. So that's the command we want to send. Let's move this over, clean these up. So now we have a little program that just homes the machine. And there could be a huge amount of code in here for a real program. So for example, a program that prints a ring, which we'll be doing later, there could be dozens or even hundreds of calls to the send command throughout the program in different places. But so now we just have one simple command. So let's go ahead and save this. And now let's write a program that calls that home program and passes in a serial sink. So I'm going to call that test serial sink. Let's go ahead and save that. And we're going to start with a serial sink. Actually, not there, sorry. On the block diagram, we'll start with the serial sink. And then we're going to call the serial sink initialize on it. And this is going to open our serial port using the Visa resource that we specify. But then we're going to call the home command on it. And remember, home is written to take a GCode sink, not a serial sink. And then after we've homed the machine at the end, we're going to go ahead and we'll close our serial sink. And that's going to be our program. So we need one other thing. We need to be able to specify the printer COM port here. So we'll add that to the front panel. And we probably, yeah, let's go ahead and do that. So we'll go to test serial sink, our front panel. And we'll go ahead and add, whoops, go ahead and add a Visa resource called printer COM port. And this will just get wired into here. This will get wired into here. And then that has an error pin, and that has an error pin. And there. So even though this guy here is expecting a GCode Sink in, I can wire in a serial sync because serial sync inherits from GCode Sink. And every time I call something that's a dynamic dispatch on GCode Sink inside of the home command, like send command, it's actually going to run the send command that's defined on serial sync instead of the send command on GCode Sink. So let's go ahead and save this all. And if I run this, it should home my printer. Oh, I actually have to set the COM port, of course. So let's go to the front panel and set the COM port. Let's go ahead and make that default. Now if I try running it, you should hear it home the printer. It was already in home position, so it didn't take very long. We'll run it again. Okay, so that's exciting. So now we have a home program that will home the printer. Let's go ahead and make a new program that's just like this, except that it writes the G-code to a file so that we can play it back later. So we're going to create a new sync, and this time we'll create a file sync. And a file sync is going to have a file reference number. So under modern, ref num, and a text file, you want to use one of these byte stream files. Oopsie. Okay, there we go. All right, so now we have a byte stream. And let's call this, what do we call it in the UML diagram? We called it the output file. So let's call it output file. And we'll go ahead and save that. So I'm going to create a new folder for my file sync. And we'll save our class into there. And go ahead and change the icon. And we'll go ahead and set the inheritance. So file sync is a type of GCode sync. And now we can override the close and send command methods. So let's go ahead and add the initialize command. And this is going to be static, which is basically not dynamic. And we need to have the name of the file. So a file path is going to be an input. Actually, let's call this and let's link that. And save it. So this is my initialize method under file sync. And let's fix the icon here. Initialize is a little too long, so let's just do init. So once again, by default, we get this case structure. So in order to initialize a file given a file name, we want to go under File I/O, Programming, File I/O, and then there's open create. And it's going to take, let me get rid of this too. So it's going to take an error in, and it's going to take a file path, and then it takes two enumerated types. So these are just basically flags, numbers that indicate what kind of thing to do. So one of them is going to be how we want to open the file. Do we want to open it? Do we want to overwrite an existing file, create, replace, and so on? The easy thing to do here is just go ahead and hover it over this pin and right click and say create constant. And this will create a constant enumerated type value that I can then click on and select what I want to do. So what I actually want to do is use replace or create with confirmation. Let's move this over, that was a little long. And then I also want to change the access. So create a new constant. And I'm just going to open it for writing, write only. So this will create a new file if it doesn't exist. It will replace an existing file with confirmation if it does exist. And it will only write to the file. And then the result from doing that is going to be an error out, and canceled, which is going to be whether it was canceled, true or false, whether it was canceled or succeeded. And I'm just going to ignore that for now. And a file ref num. So this ref num, I want to store that in the private storage for my file sync. So once again, if we look at the file sync, it's got an output file reference number and its private data. So once again, I'm going to use bundle from name, bundle by name, and I'm going to grab this file sync here for the type of the cluster, and I'm going to set my output ref num into the output file and wire that to the output. So this opens the file and stores the file reference number in the object and returns the object with the file reference number set. And I fixed the icon for that. So let me go ahead and close that. Now we're going to overwrite the send command. And show the block diagram. Okay, so if there was an error, then we're not going to do anything. If there was no error, then we're going to write to the text file. And this is going to take a file, so we need to unbundle the file. And we connect the output file into here. And we're going to take a command, and we're going to take our error input, and now we have to rebundle this. That's it. So that's sending a command to the file. We'll save it under File Sync as send command. And finally, let's go ahead and override close. And here, we're just going to close the file. Now this time I'm not going to use the case structure because I always want to close the file. Even if there was an error, I want to try to close the file. And that's it. So now we've defined initialize, close, send for serial sync. We've set the inheritance. The icons look fine. So if we've done everything correctly, we should just be able to take this test serial sync and create a copy of it. So I'm going to open an additional copy, add it to the project, and I'm going to call this test file sync. And if I've done this right, I shouldn't have to change anything in here. So all of the send commands or whatever I have in here shouldn't need to change at all. All I should have to do is instead of passing in a printer COM port, I should send a path. Instead of having a serial sync, I should have a file sync. So let's go ahead and start by replacing this. And I'm going to replace this. And now you'll notice that close automatically changed to this because it knew that I had a file sync coming across this wire. So it automatically selected file sync here. And then the only other thing I have to do is, instead of passing in a printer COM port from the front panel, get rid of that. And I'm going to add a file path. Let's make this a little bigger here. And let me go ahead and in my sync demo, I did make one mistake. I have to change one thing. So I want to call the file test output.gcode. But I can't do that right now because it says file not found. So I can only select an existing file. That's not what I want. I want to be able to specify a new file name. So let me go ahead and cancel this. And what I have to do is right click on this guy and under properties, browse options, I want to select new or existing. So this will let me specify a new file name or select an existing one. There. Now I should be able to browse here, sync demo. Go ahead and save it. So now I have my output file path. Just go ahead and connect that up. So delete this wire branch and rewire it. And that's it. So I have no errors. Go ahead and save all. And if I run this, actually, let me make current values default and save. And now run it. So that should have created a new G-code file, and it did. Test file out. So let's right-click that, edit with Notepad, and we see our output, just one line, just G28, followed by a new line. So we were able to do the output either to the serial port and control the printer, or to a file just by switching whether we were sending a file sync object or a serial sync object.